Welcome to this tutorial on creating identity matrices using NumPy's eye function. Identity matrices are fundamental building blocks in linear algebra, and NumPy provides a simple and efficient way to create them. In this video, you'll learn everything you need to know about the np.eye function and how to use it effectively in your Python projects. Let's start with the basics. An identity matrix is a special type of square matrix that has ones on the main diagonal and zeros everywhere else. The main diagonal runs from the top left corner to the bottom right corner of the matrix. Identity matrices play a crucial role in linear algebra because they act as the multiplicative identity, meaning any matrix multiplied by an identity matrix of compatible dimensions results in the original matrix unchanged. The basic syntax of NumPy's eye function is straightforward. The function is called as np.eye with several parameters. The first parameter n specifies the number of rows in the output matrix. The second parameter m specifies the number of columns, and it defaults to n if not provided, creating a square matrix. The third parameter k specifies the index of the diagonal where you want the ones to appear, with 0 representing the main diagonal. Finally, the d-type parameter allows you to specify the data type of the array elements, which defaults to float. Let's see a practical example. To create a simple 3 by 3 identity matrix, you first import NumPy as np, then you call np.eye with the argument 3, which creates a 3 by 3 matrix. When you print the result, you get a matrix with ones along the main diagonal and zeros everywhere else. Notice that the values are displayed as floating point numbers with decimal points, which is the default data type for NumPy's eye function. The eye function isn't limited to square matrices. You can create rectangular matrices by specifying both the number of rows and columns. For example, calling np.eye with 3 rows and 5 columns creates a 3 by 5 matrix. The ones still appear on the main diagonal, but since there are more columns than rows, the matrix extends horizontally with additional 0 columns. This flexibility is useful when you need identity-like matrices for specific transformations or operations. The k parameter allows you to shift the diagonal of ones away from the main diagonal. When k equals +1, the ones appear on the diagonal above the main diagonal, creating what's called a superdiagonal. When k equals -1, the ones appear on the diagonal below the main diagonal, creating a subdiagonal. This feature is particularly useful in numerical methods and when working with banded matrices in scientific computing applications. You can control the data type of your identity matrix using the d-type parameter. By default, np.eye creates matrices with floating point values. However, you can specify d-type equals int to create integer matrices, where the ones and zeros are represented as whole numbers without decimal points. You can also create complex number matrices by specifying d-type equals complex, which displays values in the format of real plus imaginary. Choosing the appropriate data type can optimize memory usage and computation speed in your applications. Identity matrices have numerous practical applications. First, they serve as the multiplicative identity in matrix operations, where any matrix multiplied by an identity matrix equals itself. Second, they're essential in linear algebra operations such as solving systems of linear equations, computing matrix inverses, and performing various transformations. Third, in machine learning, identity matrices are commonly used to initialize weight matrices in neural networks, providing a neutral starting point that preserves the input dimensions. Understanding how to create and use identity matrices with np.eye is a fundamental skill for anyone working with numerical computing, data science, or machine learning in Python.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.